Curvilinear coordinate systems 15. A particle is moving in three-dimensional space. Describe its position r of t, velocity r dot, and acceleration r double dot in terms of the spherical coordinates and basis vectors. To work this problem, it will be necessary to take time derivatives of the basis vectors because they will change as the particle moves in space. So previously we worked on these basis vectors, so we found the scale factors and then we calculated what the basis vectors should be, and here is the result. Now we have all possible coordinates here, theta and phi, that can vary with time. So we need the time derivatives of the basis vectors, as was mentioned in the problem, to solve for position, velocity, and acceleration. So here we can work on the time derivative of the radial basis vector der hat dt. And this is going to be, now if we look at the basis vector, we have, first of all, theta. So we're going to have theta dot cosine theta, cosine phi. So this is dependent on theta and phi. So the first term is theta dot, where the dot stands for the time derivative. Sine theta turns into cosine theta. Theta dot cosine theta. And then we have cosine phi in ex hat direction. And then we have to take the phi derivative of this term. So phi derivative will give us minus phi dot sine phi. So we will have minus phi dot sine theta and sine phi, and this is also in ex hat direction. Now we can work on the ey hat part. We have sine theta, sine phi. The derivative for theta will give us theta dot cosine theta. So we will have plus theta dot cosine theta, and then we have sine phi in ey hat direction. And as for the phi derivative, we're going to get phi dot cosine phi. So we will have phi dot sine theta cosine phi. The last term, cosine phi here. And this is for, again, ey hat part. So this is an ey hat. And then we have the z components where we have cosine theta. So it's going to be minus theta dot sine theta minus theta dot sine theta in ez hat. All right. Now let's recognize what these terms are. So if I look at what I have in theta dot parentheses here, I will have cosine theta, cosine phi, ex hat, and then I will have cosine theta, sine phi, ey hat, and minus sine theta, ez hat. So I recognize that I have e theta hat buried in this. So this is actually der hat dt, I recognize, is actually theta dot parentheses e theta hats. And let's look at the remaining terms. Now I have here phi dot sine theta. Here I have phi dot sine theta as well. So if I take this into phi dot sine theta parentheses, I will have minus sine phi ex hat and plus cosine phi Ey hat, which is just E phi hat. So this is plus phi dot sine theta in E phi hat direction. Now I have the first derivative of time derivative of ER hat. Let's work on the time derivative of E theta hat. So what is d E theta hat dt? For E theta hat, I have cosine theta cosine phi Ex hat. So the first term will be minus theta dot sine theta cosine phi Ex hat minus theta dot sine theta cosine phi Ex hat, and then I can take the consider the phi term. That will give me minus phi dot sine phi. So this will be minus phi dot cosine theta sine phi Ex hat. And for the Ey hat term, I have minus theta dot sine theta. So this will be minus theta dot sine theta. And I have sine phi Ey hat. And the other term is, for the phi part, I have phi dot cosine phi. So then I have plus phi dot cosine theta cosine phi so the sine turned into a cosine in Ey hat direction. And for the last term, I will have minus theta dot cosine theta Ez hat. So minus theta dot cosine theta Ez hat. Now let's recognize what these terms are. So here I have a minus theta dot sine theta cosine phi. Here I have a minus theta dot sine theta sine phi. Sine theta cosine phi, sine theta sine phi, that belongs to Ey hat. Let's check for this one, minus theta dot cosine theta Ez hat. Therefore, I recognize ER hat being buried in here. So d E theta hat dt is minus theta dot parentheses ER hat, and then I have the rest of the terms. Here is a phi dot cosine phi, here is a phi dot cosine phi. So phi dot cosine phi parentheses, phi dot cosine theta parentheses, I will have minus sine phi Ex hat cosine phi Ey hat, which is E phi hat. So this is going to give me plus phi dot cosine theta parentheses E phi hat. So that's the time derivative of E theta hat, first time derivative. If I look at the first time derivative of E phi hat, so let's also work on the E phi hat dt. The first term is minus phi dot cosine phi Ex hat minus phi dot cosine phi Ex hat, and then I have minus phi dot sine phi e phi hat, ey hat, minus phi dot sine phi ey hat, and in minus phi dot parentheses I have cosine phi ex hat plus sine phi ey hat. So that's what I have here. The e phi hat dt is in minus phi dot parentheses cosine phi ex hat and sine phi ey hat. And now I have to recognize what this is in terms of er hat and e theta hat. So if I have cosine phi ex hat and sine phi ey hat, I see that both of these terms appear in er hat and e theta hat. But if I multiply er hat with cosine phi ex hat with sine theta, then I have sine theta cosine phi ex hat plus sine theta sine phi ey hat plus for this term here, I'm going to get er hat, but there is a plus cosine theta ez hat as well. And here I have e phi, this is going to be now a sine theta cosine phi ez hat. So if this is considered, so this is multiplying it er hat with sine theta, I'm going to get a sine square theta cosine phi ex hat plus sine square theta sine phi ey hat plus sine theta cosine theta ez hat. If I were to multiply e theta hat with cosine theta, then I would get cosine square theta cosine phi ex hat, cosine square theta sine phi ey hat, minus cosine theta sine theta ez hat. When I add them up, these terms would cancel, and I would get cosine phi ex hat and sine phi ey hat. So, recognizing that, I can write this as minus phi dot sine theta er hat plus cosine theta e theta hat, because sine theta er hat plus cosine theta er hat e theta hat gives me this. So once again, sine theta, sine square theta, and cosine theta, cosine square theta. When I add them up, I would get the cosine phi ex hat that I'm looking for here. And then I would have sine square theta and cosine square thetas. They add up to 1. So I would have sine phi ey hat that I'm looking for here. And then these two terms, sine theta cosine theta minus sine theta cosine theta, they would cancel out when I add them up. So this is indeed, this can indeed be written this way. So the e phi hat dt is written in terms of er hat and e theta hat. Now we're ready to write the position vector. Position vector is particularly simple in spherical coordinates. R vector is just a radial distance r in er hat direction. So this is given. Now we can work on the velocity vector. Velocity vector is v is equal to dr dt, time derivative of the position vector. Now this is actually time derivative of the magnitude dr dt er hat plus r times time derivative of er hat der hat dt. And if we call r dot dr dt theta dot d theta dt and phi dot d phi dt, as we usually do, then we can write this as the velocity vector is equal to r dot er hat plus r der hat dt. What is der hat dt? Theta dot e theta hat plus phi dot sine theta e phi hat. So we're going to have r theta dot e theta hat plus r phi dot sine theta in e phi hat direction. This is our velocity vector. For the acceleration vector, we have to take one more derivative. Acceleration is time derivative of velocity, so it is dv dt. So for that time derivative, for the first term, we will get r double dot er hat plus r dot er hat dot plus this second term here becomes r dot theta dot e theta hat plus r theta double dot e theta hat plus r theta dot e theta hat dot plus, now we're working on the last term, r dot phi dot sine theta e phi hat, and then we have to take the derivative of phi, so we have plus r phi double dot sine theta e phi hat, and then we have r phi dot, we have to take the derivative of sine theta, so we'll get theta dot cosine theta e phi hat, and finally we will have r phi dot sine theta e phi hat dot. Okay. So let's keep this term as it is. Acceleration vector is r double dot er hat. Next I have r dot here, here, here. So let's put it into r dot parentheses. I have r dot theta dot e theta hat, the ones that don't have the time derivatives of the basis vectors. Those are the terms I'm looking at. Theta dot e theta hat, and then I have phi dot sine theta e phi hat. So the next term I have plus r dot parentheses theta dot e theta hat plus phi dot sine theta e phi hat. That's in r dot parentheses. Then I have another one that includes r dot theta dot. This is now r dot theta dot e theta hat, this term, plus r dot theta dot e theta hat. Then I have r theta double dot e theta hat, this term, r theta double dot e theta hat. Then I have the time derivative of so looking at the r theta dot terms, I have the time derivative of e theta hat. So that's this term here. Time derivative of e theta hat was given here. So I'm going to substitute that there. So I will have plus r theta dot, and then we can substitute minus theta dot er hat plus phi dot cosine theta e phi hat. So that's from the e theta hat dots, this term here. And then I have r dot phi dot sine theta e phi hat. So plus r dot phi dot sine theta e phi hat. And then I have r phi double dot sine theta e phi hat, this term, r phi double dot sine theta e phi hat. Then I have this term r phi dot theta dot cosine theta e phi hat. R phi dot theta dot cosine theta e phi hat. And then I have the last term, r phi dot sine theta. Now I need e phi hat dot, which is given here. So I'm going to substitute that. So plus r phi dot sine theta, parentheses. Then I have minus phi dot parentheses sine theta er hat plus cosine theta e theta hat. All right. So now we can write because we have everything written in terms of the basis vectors, there are no derivatives of the basis vectors remaining here. We can write our final answer by collecting all the terms that are belonging to ER hat. So the first one is R double dot. So we have R double dot. The second term that belongs to ER hat is minus theta dot square times R. So we have minus R theta dot square. And what else includes ER hat here? We can recognize this one. We have minus phi dot square sine theta times R sine square theta times ER hat. So we have minus R phi dot square sine square theta, and these are all the terms that belong to ER hat for acceleration. Let's look at E theta hat terms. We have R dot theta dot E theta hat here, R dot theta dot E theta hat here, so twice 2 R dot theta dot. And then we have another E theta hat term. Let's find the other E theta hat term. R theta double dot. So plus R theta double dot. And finally, the last term here includes cosine theta, sine theta minus phi dot square times R. So minus R phi dot square sine theta cosine theta, and these are the terms that belong to E theta hat. And similarly, we can recognize the terms that belong to E phi hat here. So scanning, the first one is R dot phi dot sine theta in E phi hat. And then we have R theta dot phi dot cosine theta. And then we have R dot phi dot sine theta again. So this term is repeated, and R theta double dot, R phi double dot sine theta term, and then we have R phi dot theta dot cosine theta E phi hat term is repeated. So we have 2 R dots phi dot sine theta plus 2 R theta dot phi dot cosine theta, and then we have R phi double dot sine theta. This is all in E phi hat direction. Therefore, this is our final answer for the acceleration vector. Okay, so in the first part of the problem, we worked out the basis vectors ER hat, E theta hat, and E phi hat, written in terms of the Cartesian basis vectors EX hat, EY hat, EZ hat. Then we have taken the first time derivatives, and notice that d ER hat dt is related to E theta hat and E phi hat. dE theta hat dt is related to ER hat and E phi hat. And likewise for dE phi hat dt, we have ER hat and E theta hat dependence written this way. Now position vector is r in ER hat direction. Then we can start taking derivatives. Velocity is dr dt, which is r dot ER hat plus r dER r hat dt. For dER hat dt, we substitute this, and that's what we get. And for the second derivative, we will obtain acceleration. This will give us r double dot ER hat, r dot dER hat dt, r dot theta dot E theta hat, r theta double dot E theta hat, r theta dot E theta hat, dE theta hat dt, r dot phi dot sine theta E phi hat, r phi double dot sine theta E phi hat, r phi dot theta dot cosine theta E phi hat, and finally r phi dot sine theta dE phi hat dt. For dE phi hat dt, we substitute this. For dER hat dt, we substitute this, and do we have E theta hat dt? Yes, and for that one, we can substitute this. So that's what I have done here. So here's the first term, r double dot ER hat. So then I have r dot dER hat dt. This is dER hat dt substituted here. Then I have r dot theta dot E theta hat. Then I have r theta double dot E theta hat. Then I have r theta dot dE theta hat dt, which is substituted here. And then I have these terms, and for the last one, I substitute dE phi hat dt, and rearranging them and looking for the ones that have ER hat, E theta hat, and E phi hat terms in. So the prefactors are calculated here, so I can know the acceleration's radial component, polar component, and azimuthal component.